Right, so when we dealt with nature of costs and variable and absorption costing, we saw that labor time is an important component of calculating cost of production. So the learning curve theory basically suggests that a task that is repeated continuously obviously tends to become easier, and with experience the average time should drop. So when you perform a task for the very first time, and let's assume you're manufacturing something for the very first time, obviously there's a learning curve. We will encounter problems, we will make mistakes, etc. But the more times we repeat the manufacture of that particular product, the easier it will become, and the amount of time will drop as we learn to do this. So the theory behind this basically suggests that every time the number of units double, the cumulative average time per unit will be a fixed percentage of the previous cumulative average time per unit. So in other words, it basically forms a pattern. We call that pattern a learning curve. Okay, so the best way to give you an idea of this would be to do a basic illustration so you can understand the concept of the learning curve, the cumulative average, the fixed percentage, etc. So let's start with illustration 1. Okay, it says that a person takes 10 hours to complete the first unit, and the second one only requires 8 hours to complete. So obviously with a bit more experience we've circumvented some of our problems, etc. Right, so what we're going to do is we're going to use this information. There's 2 bits of information. Unit number 1 took us 10 hours and unit number 2 took us 8 hours. We're going to take this information and we're going to calculate what we call the learning curve or a learning rate, and it's also important to understand the difference between those two. And then also we can take that further and calculate what number of hours it would require to make additional units. Now remember, we said that the theory suggests for every doubling of the unit. So in other words, when 1 doubles to 2 and 2 doubles to 4 and 4 to 8 and so on. Okay, now to calculate the learning curve, the formula is essentially the same. All we've done is we've put it into different sort of context, different wordings, if you want to call it that. Okay, so what we do in the first example is we take the time for the first unit and we add to that the time for the second, and we divide that by the time for the first multiplied by 2. Okay, so according to our information, it took us 10 hours to produce the first unit. So there's my 10 hours. And it took us 8 hours to produce the second unit. We divide that by the time for the first, which is 10, and we multiply that by a constant of 2. Okay, now you'll see where the 2 actually really fits in. Okay, it's just an inverted formula. Right, so therefore 18 over 20 is equal to 90%, or 0,9. Now, usually you would associate the word rate with a percentage, but not in this case. In this case, your rate is a decimal while the curve is a percentage. It is essential that you make that distinction. Okay, if we had to move the formula around and just change it a little bit, okay, we could rewrite that formula as the cumulative average, in other words current, divided by the previous cumulative average. Now, if I made 2 units and the total time for the 2 units was 10 plus 8, which is 18, the average time is obviously 18 divided by 2 because they're 2 units. So my cumulative average is 9. My previous cumulative average was when I only produced 1 unit, and 1 unit took me 10 hours. So 10 divided by 1 is 10. And that gave you the 90%. Now this formula is a lot more useful when a question, for example, tells you that the total amount of time for the first 8 units is, let's say, X, and the total amount for the first 4 units is, let's say, Y. They've given you total. You've got to work out the averages. So we'll come to an illustration like that. Okay, so that's how you would calculate your learning curve or your learning rate. So that fixed percentage that we spoke about in the initial definition Okay, when we spoke about a fixed percentage, our fixed percentage is 90%. Okay, now how does this work? We're going to illustrate this with three basic methods. Let's start off with let's call it the table method. Okay, you could put this into a nice table. Okay, so the first unit took us 10 hours. When we double those units, okay, we multiply the 10 by the fixed percentage of 0.9, and that equals to 9. Okay, now what is that 9? That 9, okay, is the average time for the first 2 units. Okay, so 10 times the fixed percentage is equal to 9. 9 is the average time for the first 2 units because I've just doubled from 1 to 2. If I want the total time for 2 units, obviously I take the average for 2, multiply by 2, and I get 18, which takes me to the total for the first 2 units. When I double the 2 to 4, okay, note what I do. Okay, I take that 9, in other words, the previous cumulative average, and I multiply that by 0.9, which is my fixed percentage, and that again gives me what? That gives me the average for the first 4 units. Now, if I want the total for the first 4 units, I multiply that by 4, and I get 32.4. And we can repeat the process as long as the learning curve lasts. Now, the learning curve will never last forever because at the end of the day, if I say to you that the learning curve lasts forever, eventually the units would produce themselves, which obviously doesn't make any sense. So there is a saturation point where the number of units, obviously, or the amount of time, the average time that is required to produce these units would saturate, and then the average continues for further units. Okay, so that's the table method. It's very sort of based on basic arithmetic, and you can use this at any point in time. Obviously, there are 2 other methods which you have to know because, again, you don't know what's going to happen in the exam. The exam might specifically say use one of the other methods. Right, so let's go and have a look at the other methods. The next one is called the Exponents Method. Now, the Exponents Method is just another way of writing what we did earlier. Okay, what we do is we use a base 2 log. Okay, so for example, if I wanted to work out, let's say, the total amount of time for 8 units, we know that 2 as a base to the power of 3 would equal to 8. Okay, so for example, if I had to say 4, then I'd say 2, which is my base, to the power of 2. Okay, if I had to work with 16, then that would be 2 as a base to the power of 4. Okay, so in this example, I'm working with 8 units, so let's see what happens. So what I do is I take my learning rate of 0.9 and I use the 3. In other words, that 3 is that 3. So 0.9 to the power of 3, and I multiply that by the time for the first unit, which we said was 10, and that answer would equal to the average time for the first 8 units, which equals to 7.29. Now, let's go back quickly. Let's just compare that number, right? And there is my average of 7.29. All right, all I did was I used a slightly different way to do that. Now, that way is nothing more than a summary of what we did in the table, okay? Because notice essentially what I've done. Right, now that should be a 0.9. Okay, so what we've done is we've taken 0.9 once, 0.9 twice, and 0.9 3 times, okay? Which gives you what? 0.9 times 0.9 times 0.9, which is 0.9 to the power of 3. So that's just a quicker way of dealing with it. So the exponents is just a shorter version of the table, basically. Okay, and again, to multiply that by 8 will give you the total time for 8 units. Okay, now the last method is based on logs. Okay, Chance of this coming in the exam is slim, but you still have to know it, because if the question is specific, you have to know how to apply this. So we use the formula y is equal to ax to the power b. Firstly, note that b is only on the x. In other words, the exponent only relates to the x. Okay, it doesn't relate to the a. Okay, what does a mean? A represents the time for the first unit, okay, which in our case was 10. X represents the cumulative number of units, which in our case was 8. And B, basically B is the log of the learning curve over the log of 2. And on your calculators, you should have a key that we often call ln, Ln, which is the natural log. Okay, so what we do is we find the natural log of 0,9. We divide that by the natural log of 2. The 2 is the constant, and you will get negative 0,152. Okay, and where does it end up? As an exponent for the 8 only. Okay, and notice what happens. The time for the first unit was 10, and look what we get to. We get to 7,29. So therefore, what does y actually represent? Y represents the average time for the first 8 units. And there's the 7,29.